I've been at Loughborough University for 4 years now, and now I'm taking my research into the commercial side of it and going to work for a big shoe brand. We are surrounded by shoes, as this has been the focus of my PhD. So this has really been my passion for the past 3 years, the manufacturing and human performance testing of the shoes you see in front of you. So these particular shoes are very specific to sprinting. So what we've focused on is developing sprint spikes. So as you would see an athlete in the Olympics or any kind of elite sprinting event wearing. So they've got particular traction needs, and these shoes are built for performance. In a foot strike, we're looking at the bending stiffness about the metatarsal joints or the toe joints across there. So that's where the majority of the bending will occur. So we're looking at shoes that are quite flexible, that you would typically see commercially available. And we are increasing the stiffness, something very stiff that I can't even flex here. So my interest in this area and this topic came as I was studying my mechanical engineering degree and running for the university track and field team as a sprint hurdler, looking at the type of shoes that people buy, and the choices typically made on color or fit. Everyone had their own individual idea of their optimal shoe. You know, this one was stiff or this one was least stiff, but no one had any performance indicators to kind of show which ones are better. The elite athlete is a particular breed, and you have to be very mindful of the time of season that it's in and with their competition schedule. We're looking at improvements in the order of 1%. If you can improve an athlete's power output by 1%, that could be the difference between being first and being fourth, fifth, sixth. Perception is very important. We don't want to influence an athlete if something doesn't feel right and they're adamant. But when you can show them a shoe that's very stiff, that they can't bend, showing them the high-speed video footage of them running in them and actually how much it does bend with how much force they're putting into it, it does change an athlete's perception. In order to look at such small improvements in performance, you need really precise instruments that are going to measure very small changes in the kinematics, which is the motion of the athlete, and the kinetics, which is the forces that the athlete can output. What we're looking at here is a drop jump. Now that replicates the forces that an athlete would typically produce in the maximal speed phase of sprinting. What you'll see here as well is a massive arrow shoot up, and that is representing the force that's being produced as he's in contact with the ground. When you can explain the science behind it, people are a lot more receptive to it, and I think it is demystifying the science behind it, and it really isn't that complicated. It's taking general mechanical principles and applying them to sport. Being able to make a difference to an athlete standing on the start line gets me up in the morning. It's knowing that an athlete is going into a competition with every tool to their advantage and having that confidence behind them that they know that they have done absolutely everything to achieve their goals. I know how hard an athlete works to achieve a goal and to work to get to one competition, how many hours, days, weeks, years go into that one race. And I want to make sure that they have every advantage possible.